Hello students, I have come up with one more challenging problem for you. The problem is like that, you see, it is a inward magnetic field. Here, crosses means inward magnetic field, and there's a wire frame, U-shaped wire frame with this resistance. On this U-shaped wire frame, it is a rod which slides. The frame is horizontal, not like vertical and it will fall off like this. It is a horizontal frame on which there's a rod. It slides on the frame, or you can push it and it moves in the forward direction. The question is, when if you give an initial push to this rod in the forward direction, there will be some forces on this rod in the back direction. I will explain how. And when there's a backward force, you are giving initial velocity v0. What distance it will cover before it stops? That's our question. The question is, if you are given initial velocity to this rod, it will move and then finally it will stop. I have to find what is the distance it covers before it stops. कितना आगे जाकर ये stop होगा, वो हमें निकालना। लेकिन बहुत सारे क्वेश्चन इसमें है कि वैसे अगर ये आगे जा रहा है वेलोसिटी से, तो what stops it? There must be a backward force that stops it. तो वो backward force कहां से आता है, वो देखना पड़ेगा। और फिर जब ये आगे जाएगा मूव, तो ये मैग्नेटिक फील्ड को कट कर रहा है। मैग्नेटिक फील्ड इज इनवर्ड्स एंड द रॉड इज मूविंग लाइक दिस। मैग्नेटिक फील्ड इज इनवर्ड्स एंड रॉड इज मूविंग लाइक दिस। ये मैग्नेटिक फील्ड को कट कर रही है। When it cuts the magnetic field, obviously there will be an induced EMF that I will explain you. So there will be induced EMF and that induced EMF will send current. And now इस रॉड के थ्रू करंट जा रहा है, and इस रॉड के थ्रू करंट जाने की वजह से it's a current carrying conductor in the magnetic field and there will be a force. So first of all, the rod is in the magnetic field and is given initial velocity v0. Find the distance the rod moves before it stops. That's the question. You are giving initial velocity to the rod and the rod will stop somewhere. We have to find कितना distance उसने cover किया before it stops. तो ये है हमारा क्वेश्चन। लेकिन पहला कॉन्सेप्ट जो इसमें है कि रॉड इन द मैग्नेटिक फील्ड में जब रॉड होता है तो और मूव कर रहा है तो क्या होगा, फोर्स ऑन द रॉड कैरिंग करंट। कितना फोर्स होता है रॉड पर जिसमें करंट होता है, विच कैरीज करंट। दैट इज समथिंग दैट वी हैव टू अंडरस्टैंड। तो अब मैं इस क्वेश्चन को करना चाहूंगा थ्रू स्टेप्स। फर्स्ट ऑफ ऑल, इट इज अ रॉड मूविंग इन द मैग्नेटिक फील्ड। It is magnetic field, is the rod moving in the magnetic field. पहला क्वेश्चन ये है कि जब रॉड मैग्नेटिक फील्ड में मूव कर रहा है तो what will happen to the rod? And I will tell you, when the rod moves in the magnetic field, there exists a potential difference across the rod. So something like this. Have a look. अगर ये मैग्नेटिक फील्ड है, ये मैग्नेटिक फील्ड समझो आप, इनवर्ड मैग्नेटिक फील्ड, क्रॉस मींस इनवर्ड्स, अगर डॉट होता तो दैट वुड मीन आउटवर्ड्स। तो ये रॉड इसमें से मूव कर रहा है विद वेलोसिटी v, लेट मी सपोज। जब ये वेलोसिटी v से मूव करेगा तो व्हाट हैपेंस, इसमें अगर आप पॉजिटिव चार्ज कंसीडर करेंगे, इलेक्ट्रॉन से भी वही होता है। इफ यू कंसीडर पॉजिटिव चार्ज इनसाइड द रॉड, वही होगा। तो पॉजिटिव चार्ज अगर इसमें है, दैट मींस पॉजिटिव चार्ज आर मूविंग इन द फॉरवर्ड डायरेक्शन। तो मैग्नेटिक फील्ड इज इनवर्ड्स, पॉजिटिव चार्ज आर मूविंग लाइक दिस along with the rod in the forward direction, and that means positive charge is moving in the magnetic field. So velocity of the positive charge is the same as this v in the forward direction. तो उस v को b में क्रॉस करो, the charges are pulled in the upward direction. So this will become positive, this will become negative. So it's a Lorentz force on the charge which pulls the charge in the upward direction. Something like this. It's a rod. It's a magnetic field is a rod. And rod is moving like this, means positive charges are moving like this. So there's a force on these positive charges. That force is v, that is this, cross b. Charge will move upwards. That means upward will become positive, this will become negative. तो इसका मतलब यही है कि when the rod moves in the magnetic field, cuts the field lines, there will be induced EMF. Charge will surge towards one end. One end will become positive, other end will become negative. That is the rule. Base concept. When the rod cuts the magnetic field, moves through the magnetic field, cuts the field lines, then one end of the rod becomes positive and other end becomes negative because of the Lorentz force. Lorentz force will surge the charge, it will push up the charge towards one end, and obviously if positive charge go to the one end, the other end will become negative. Or you can conversely say the negatives are coming down. It is the same thing. The fact is the rod contains free electrons and free electrons come down. But that means the same thing as positive charge has gone up. It's a polarization sort of a thing. If this end becomes deficient of positive charge, it becomes negative. If this end becomes deficient of negative charge, it becomes positive. That's the first concept is this. When a rod cuts the field lines, due to the Lorentz force, one end of the rod becomes positive and the other end of the rod becomes negative. That's all. अब देखने वाली बात यह भी है कि अगर मैं इस एंड को यहां कनेक्ट करूंगा टू ए रेजिस्टेंस, this means this positive end will send current. It acts as a battery. It will send current to this resistance like this and like this, and the current will flow through the rod. Now when it sends the current through this resistor, the current comes back and passes through the rod. Now the same rod whose motion produces the induced EMF, उसी rod के through current जा रहा है. Now it's a current carrying conductor in the magnetic field. Therefore there will be force on this. It's a current moving upwards. Now in the same rod, current is moving upwards and magnetic field is inwards. It is the current moving upwards. Here look, current moving upwards because of this mechanism. When current moves up, magnetic field is inwards. I cross B force is like this, because when a current carrying conductor is in the magnetic field, there will be a force on the conductor. And we know the relationship of that force. So that will be force will be created. The direction of the force will be I, L cross B. L is this, B is this. You cross L into B. L is this, B is this. You cross L into B and thumb gives the direction. That means force is this direction. तो वही कुछ उसमें वहां हो जाता है. जब आपने इस रॉड को आगे की ओर मूव किया तो that creates current. Current flows through the rod and on the rod there is a backward force. And now this force retards this rod. ये rod आगे जाना चाहता है, force is backward now. Now this will slow down. That is the concept. But before I do that, what's the potential difference created in the rod because of this velocity? Potential difference that is induced is V, velocity of the rod, this V, L, length of the rod, and magnetic field. This is the rule. Because here velocity, magnetic field and length, they are mutually perpendicular. This is rod, this is magnetic field, and this is velocity. This is velocity, this is rod, and magnetic field is inwards. This is perpendicular to this. Rod is also perpendicular to magnetic field. Velocity is also perpendicular to magnetic field. And under those conditions, the induced is VLB. अगर 90 angles का नहीं होता, कुछ और angles होते, तो this would not have been the relation. Relation is much that relation is more general. तो वो यहाँ पर याद रखो तो ठीक है, नहीं तो मैं किसी दूसरे लेक्चर में वो बता सकता हूँ. Actually, it is V cross B dot L. The new EMF is actually this, but V and B are perpendicular. It is VB. L is also perpendicular. V cross B L और parallel हो जाता है, क्योंकि V cross B जब निकालोगे वो L को parallel हो जाएगा, तो that will be simply like this VBL. V cross B is VB, L को dot करने से वो VBL हो जाता है. It's a special case when L, B and V are mutually perpendicular. But in general, this is the case. Induced EMF is given by this relationship. Okay. Now let me go to the problem now. What's this force acting on the rod? That force is I, current in the rod, L cross B. ये है force. मगर चूंकि L और B perpendicular है, it will be ILB. Direction बताया, direction is backward. जहां से वेलोसिटी मोशन दोगे, फोर्स उसके अपोजिट होगा. अगर आपने वेलोसिटी का डायरेक्शन ये दिया होता यूं, तो फोर्स वुड हैव बीन लाइक दिस. अगर वेलोसिटी यूं है तो फोर्स इज लाइक दिस. तो फोर्स इज ऑलवेज अपोजिट टू द मोशन ऑफ द रॉड, बिकॉज द मैग्नेटिक फोर्स विल नॉट अलाउ द रॉड टू मूव. इट ऑलवेज wants to rod to stay at its own place. If you give motion to the rod like this, force is like this. If you give motion to the rod like this, force is forward. Okay, now let me go to the problem now. Explaining these concepts, let me go to the problem now. First of all, When you give any generalized velocity, if you give any generalized velocity, what is the induced EMF of the rod? Which end will become positive? This one become positive, because rod is moving in the forward direction, magnetic field is inwards, so V is forward, B is inwards, V cross B upwards, positive charge will be up and negative charge will be here. So the current will flow like this, and current in the rod will be like this. Now it is when current flows, this is a current carrying conductor in the magnetic field, and it will experience force. That force has a direction of this. So first of all, what is induced EMF? That is V, B and L. L is the length of the rod. Equation first. This is the induced EMF. ये जो induced EMF प्रोड्यूस हुआ इस मोशन की वजह से, इसने कितना करंट प्रोड्यूस किया in the external circuit of this resistance? How much? How much current it will produce in the external resistance? That current will be simply induced EMF, that is E by R. Induced EMF by potential difference by resistance. So it is V B L by R. Equation number second. So this current flows also through this rod. So now what is this force? Backward force on the rod due to this current flowing through the rod, because now the rod is in the magnetic field. So force is equal to I L B. It is actually I L cross B, but L and B are perpendicular, so it's I L B. So I substitute, you substitute for I. So V B L by R, that is I L and B. That is force is equal to V B square L square by R. This is the force. So this much of force is acting in the backward direction, but you have given a velocity of V0 in the forward direction. ये velocity आपने forward direction में दी. Obviously क्या होगा, इस force की वजह से जो backward force है, इस force की वजह से ये retard होगा. It will go on retarding down and finally it will stop. हमें देखना है कि after how much it covers a distance, some distance and then stops. How much distance it has covered before stopping. स्टॉप होने से पहले इसने कितना डिस्टेंस कवर किया. तो क्या किया जाए? तो यू ऑलरेडी नो F इज इक्वल टू एम ए इज द रूल. ये कि मास दिया होना चाहिए रॉड का. द मास ऑफ द रॉड इज इक्वल टू एम. मास दिया होना चाहिए. अच्छा, व्हाट इज एफ? व्हाट इज द एक्सटर्नल फोर्स ऑन द रॉड? It is this V B square L square by R. Negative, because backward. It is M. What is the acceleration? You generally write acceleration dV by dt. You generally write acceleration A equal to dV by dt. That is what you write. Rate of change of velocity with time. But here I will write V dV by dx. For acceleration, I will write this. I will prove it in a moment. Okay, let me prove it here. It is dV by dt. Let me say it is dV by dx into dx by dt. Same thing, dx cancel, it is same, again the same thing. Magar, what is dx by dt? That is V dV by dx. So this is equal to this. dV by dt, it's dV by dx, and also write dx by dt so that this cancels and you are left with the same thing again. What is dx by dt? That is V and dV by dx here. Okay. Now V and V cancels. What should I write? Minus B square L square by R is equal to M dV by dx. ऐसा equation. So what is dV equal to? dV is equal to minus B square L square MR नीचे और dx ऊपर. सिंपली ये dV dx यहां, M नीचे और dx यहाँ. Okay. Now what you are going to do with this now? चलिए, it is dV is equal to minus B square L square by MR, R is resistance, and dx. Integrate both sides. Initial velocity जो आपने दिया कितना था? V0. So initial velocity is V0. Final velocity जब ये स्टॉप हुआ that is okay 0 because it stops there. Initial position, let me suppose 0, initial position was 0 this, and final position x. जो हमें यहाँ x मिलेगा वही तो ये distance है, because we have given the last velocity 0. So जो ये x यहाँ हमें मिलेगा that will be this x. Okay, now this cancels, differential and integral cancels, so it is v under limits of 0 and v0, that will be 0 minus v0 is equal to, okay, b square बाहर, l square बाहर, mr बाहर, नेगेटिव साइन के साथ ही इंटीग्रेशन dx का होगा दैट इज x माइनस 0. यह बाहर निकलकर इंटीग्रेशन इसका होगा. जब इस इंटीग्रेशन इसका होगा d और इंटीग्रल कैंसिल हो जाएगा तो x अंडर व्हाट लिमिट्स, x and 0, so it will be x minus 0. 0 and 0 cancels, so it is negative and negative cancels, sorry, negative and negative cancels, b square, it is l square, it is m or x. So what is this x? Distance covered before it stops, that is v0, m ये वाला, r ऊपर जाएगा by b square l square. That is the answer for this problem. It is this distance which it will cover before. हाँ, obviously अगर आपने initial velocity ज्यादा कुछ दिया, ज्यादा ही कुछ दिया, तो obviously it will go far off before it stops, बहुत आगे जाएगा इस ज्यादा v0 की वजह से. So that was the problem. It was basically a problem when you current carrying conductor in the magnetic field. When you push it, current flows through the same conductor and there's force on the same conductor. तो आपके पुश देने की वजह से उस पर फोर्स क्रिएट हो जाता है in the magnetic field, opposite to your push, opposite to your velocity push. This is the 9th challenging problem, and challenging problem will be delivered on the daily basis. You go on watching on these challenging problems on my YouTube, and also you can download the literature from my application, that is Not Listen Physics Class. Thank you.